If you need 2 words to describe this group, it's probably memorable and noisy. When Block Party first started, their demo looped endlessly to the point that I had to get up and dance in front of it. And the second demo was disqualified. But the discussion about that disqualification led to a linking at Hope last year, where I invited this group to come speak here at NOTACON and Block Party. This is CriticalArtware, who are part of a whole scene of people pushing the boundaries of what art, computer technology, and audience toleration can handle. So, with no further ado, CriticalArtware.
Hi, thanks for coming. So, yes, we're CriticalArtware, and my name is John Cates. One of the first things that we're going to do is we're going to sort of walk through what happened that Jason just told you about. So we want to make that really clear to everyone so everybody understands where we're coming from. So at the first block party, as Jason said, we had a demo in that block party, and that was called Chassis, and it made the competition. It made eighth place out of 8 entries. So yeah, but you know, some people might consider that, well, losing or something. But when Jason got up and danced in front of it, I mean, you can really consider that winning. So we wanted to show you first what that looks like, and it looks like this. We thought that was like a reasonable claim to start off with. Okay, and then we have some shout outs. So you can see that we're working here with some of the accepted conventions of a demo, working within the genre of a demo. But what we're also working within is the genre of artware, which is software as art, and also dirty new media art. So we're looking for a combination of these 2 worlds, and that's what we're working on, is artware demos. And again, as Jason told you, he got up and he performed, he danced to this, which was fantastic. And we were so excited by that we wanted to fold that into our next demo. So at the next block party last year, we entered a demo that I'll show you, an artware demo. And yeah, it includes the material, the footage of Jason dancing in front of the first demo. So it's recursive, it's self-reflexive. this is usually where the computer crashes. So this is using a distinctive feature of Artware, which is to have multiple windows. And it's also using distinctive features of the demo scene. And there's an air horn. And as Jason said, this was disqualified from the category of the standard demo. But in fact, this Artware demo actually won the secret Artware category. So again, we have a kind of complex relationship here between winning and losing, let's say. So it seems to have concluded or crashed either way. And I'll go ahead and shift at this point. To a different computer, since that one has been disabled by our Artware. Okay, and so the subject of our talk today is how we do what we do and how we make the Artware demos that we're making. So what we'll be looking at are the authoring environments for our Artware demos. And in order to do that, we're also going to show you other Artware demos that have been made by other crews and other artists at different times using our operating system. So the first thing that you'll have to get used to and have to notice about our operating system and our Artware authoring environment is that it's web-based. The reason why it's web-based is because we often find ourselves in different physical locations, decentralized. While we're based in Chicago, we spend time in different places. So we work together across the network in a decentralized manner. And that also means that you're going to see different flavors or installs of our Artware authoring environment because each of us has our own flavor. Okay? If you lick us, you can find out about that later. This is a really famous example of a crew called Jody. Jody.org is a really well-known Artware demo crew, and they're working in our operating system. You can see here that this is, again, using that classic distinctive feature of the medium, which is multiple windows that are auto-generating and that are moving or dancing, you could say, around the screen. Now, if you were to run this on your own machine, it would be running full screen, but I'm rendering it here within our operating system, so of course it's contained within the operating system. Partially that's also to keep it contained in the context of this talk. This is, again, really well-known piece from about 2001, web-based and also for download, again, by the Artware demo crew, Jody.org. And this is another extremely well-known piece by the same crew, and it shares some other distinctive features of the medium. You can see that here there's a code layer layered on top of the visual layer, so you have a multiplicity of visual layers to contend with, and on this top layer, there's the code layer. Obviously, people recognize that this is HTML code because, again, this is another web-based, browser-based Artware system. So this is a piece by, again, the Artware demo crew, Jody.org, and what they did is they crafted their own browser, their own web browser. This piece is called Wrong Browser, and it's from, again, the same time period, 2000, 2001. So it's rendering the HTML code in this manner and running in this manner. This is the co.kr version. You can see that down here. And also you can hear there's a bit of a dirty new media sound to it. There's a bit of a noise, glitch, kind of a rough sound to it. So again, this is to connect with some other people who are using our operating system to make work and to attempt to contextualize that for you. This is a fully functional web-based Artware browser. You can browse any online resource this way and parse any available code this way. Yeah, and it also has formal aspects that are similar to what you'll see with our Artware demos that we're making. Again, because yeah, they're working in our same operating system. So you could also consider this a form of experimental media. And here you see that I've accessed NOTACON.org. So NOTACON.org is currently being processed by wrong browser. And I'll go ahead and access blockparty, and we'll go ahead and process blockparty this way. So now we're processing NOTACON.org and blockparty with the Artware demo crew, Jody.org's wrong browser Artware demo. And I hope you get a feel for how that is. Okay, there are 3 of us, so we have to, yeah, maintain our time here. So this is a very important Artware demo, which was made by an artist named Ido Stern, and you can see here that it's using our spiral tunnel generator, and maybe what is not what you need to keep in mind, what's important for you to keep in mind, is that what you're looking at is very large-scale public sculpture. So that's important for you to know. And again, it's being rendered and run in real time in our Artware operating system. And it's an infinite spiral tunnel. So again, this is a very direct connection to, yeah, it's the connection that we feel very, very close to and that we feel is very important. So again, I've showed you a little bit about our operating system, and now we're going to kind of peel back the metal, and we're going to get a little bit low level, and we're going to talk about deprogramming and reprogramming crickets at a really low level, close to the metal, gritty, dirty new media way. And so I'm going to step down.
Hi. So my name's Jake Elliott. I also work with CriticalArtware. And the component of the Artware development, Artware environment that I'm going to walk through with you guys is kind of how we work at a very low level in a manner that you're probably familiar with in the demo scene, similar to doing assembly coding or other kind of low-level machine code. This is our low-level system through which we reprogram crickets. And it's called the low-level meta-assembly mindfucker. And this is an early version of it. This is version 0.23. We've been working on the system for a long time. As you'll see, there's a lot of work that's been built on top of this system that goes back for years and years. But we're still at a very early version number. We want to consider this project always kind of in evolution. So first off, I'm going to show you a chunk of this. And this is how we kind of got to this place where we were reprogramming crickets at a low level. We were working with software made by this artist, NOTACON Nesvanova. And she's a software artist. She builds different kind of software environments for making experimental music and video art and VJ applications. We were doing some VJ work, and we wanted to use her software to do that work, but it's very difficult to get a hold of. So we emailed her and asked her about it, and she wrote us back and told us something that really kind of blew our minds, which is that she doesn't program software anymore. Because as you can see, I've highlighted it here. Anybody can program software. She programs crickets. So we picked up on that and really decided that we were going to learn how to program crickets. It sounded like a much more radical way of working with software art. So this was an early prototype. This is running on our low-level meta-assembly mindfucker, and this is a cricket reprogrammer. So you can see these images move by at different speeds, kind of reprogramming the psyche of the cricket at a very low level, making new associations, destroying old associations. It works at the level of neurons or neuron opcodes or neuropcodes. Okay. So moving on from there, we've worked with a lot of different artists and software developers who have built on top of our system to make different kind of tiers or layers of abstractions on top of the low-level meta-assembly mindfucker. One of these artists is Mez, who's an Australian artist who's devised a language for the same kind of thing, neural code reprogramming for crickets, but it's a higher level language, and it lets her work in a way that makes more sense to her as a cricket. So I'm going to show you some of what her code looks like. This is the language Mesengel that she's implemented. And it works by making associations between words, by making word intersections, kind of like a crossword puzzle, kind of like a low-level assembly mindfuck crossword puzzle. But as you can see, this is a fairly high-level language. This is actually built on top of low-level assembler neuropcodes. So we have a decompiler because we built the system. We know how to do this kind of thing. So if I transpose exa here, this is the low-level metasymbolic neuropcodes that produces this higher-level language. So we can make changes at the level of the neuropcodes and see them reflected in Mez's code. So I'm just going to take out these two pops. These are kind of like assembly statements, and untranspose exa them. And there you see it. It's a radically different program. It does a radically different thing to your mind. So that's one layer of abstraction. There's another artist that you may be familiar with from her work within the demo scene, but she's done a lot of work outside the demo scene too, named Yoko Ono. And Yoko Ono built a two-tier metasymbolic neuropcode reprogrammer on top of the low-level metasymbolic mindfucker. And it was called Grapefruit. It was kind of like have you guys ever seen punch card programming or punch card systems? It was kind of like that, but instead of holes in the punch cards, she put letters there. She put text there. So I'm going to show you a couple different subroutines from the Grapefruit program. This one is called City Piece. And it's just a series of instructions to be executed by a cricket. Step in all the puddles in the city. So the reason that this is a two-tier metasymbolic neuropcode reprogrammer is that these instructions are in a very high-level language. It's very similar to English. It might look a lot like English to you. And when read, these get executed physically by crickets. And then their brain reads the physical actions that they're executing and rewires them at the level of conception. That's why this kind of demo art is called conceptual art. Maybe you've heard it. There are quite a few of these programs. I'm going to show you just a couple more. Number 8 is pretty good. Make a key, find a lock that fits. If you find it, burn down the house that's attached to it. So we've seen 1 tier and 2 tier. Now let's look at n tier. This is a level of abstraction that can go into infinite regress. This is a piece this is kind of a reference to a piece by an artist named Cornelia Solfrank. And this piece was called Female Extension. She used our low-level neurocodes to implement the piece. Basically, in 1997 or so, an art museum in Hamburg in Germany had a net art competition. And Cornelia's response to this was like the first net art competition. Her response to it as a cyber feminist was to create a piece of software that created net artists, and specifically female net artists. So she created 200 female net artists and then used additional software for those net artists to create net artworks and submit them into the competition rather. So here we have some scrolling shout outs to all the different female net artists that she generated. This is another point of connection that we find with the demo scene, the scrolling shout-outs. And also the psychedelic color cycling is another point of connection. And then another really important point of connection is the spiral 3D tunnel hypno effect. That I'm going to show you our spiral tunnel generator that we use called the Animus Cinematic Tunnel Variant Automata. Okay, so we have a few different presets. I'll just show you presets. It's really kind of boring programming at the low level, but it's exciting what comes out of it. So here's one tunnel that can be generated. This is another tunnel that can be generated. These tunnel effects are generated using 16mm film, glass, reflections, and drawings. This is one of my favorites. I'm going to show you a demo that was created using our 3D tunnel generator. This demo was created in 1926 by the artist Marcel Duchamp, who was in a Swiss demo crew called Dada. is actually a video of the demo. Because the original demo is implemented using motors and glass and 16mm film, which they wouldn't let us take on the Megabus. So we shot this video of it. And there's another thing that I want to point out about these spirals, which is that they themselves work as low-level meta-assembling mindfuckers. If you follow the outer white contour of the spiral, I want you to just look closely at the white part of the spiral and just follow it as it spins around. And while you're following the white part of the spiral, I want you to listen very closely to the tone of my voice. You're watching the white part of the spiral and you're listening to the tone of my voice. And as you follow the contours of the tone of my voice, your shoulders begin to relax. And the more your shoulders relax, the more your elbows relax. And the more your elbows relax, the more your shoulders relax. And your eyelids are getting heavy. Your eyelids are getting heavy. The spiral's spinning. You're watching the white part of the spiral, and your shoulders are relaxing. You feel adrift, as though your consciousness is a lotus flower floating in Lake Erie. And as the spiral turns, a certain phrase bubbles to the surface of the lake. That phrase is cool class code. You recognize this phrase from somewhere, but you're not sure where. But you know that every time you hear this phrase, you're going to think that you're watching the most amazing demo you've ever seen. It has 3D tunnels. It has 4D tunnels. It has metaballs within metaballs. It has meta-metaballs. Now your shoulders are relaxing, your eyelids are getting heavy, and you're falling asleep. And when you wake up, you won't remember anything that's happened in the last 26 minutes.
Hello. Hey, I'm Tomas Kensi, and we're CriticalArtware, and we're from Chicago. We're an artware demo group, and I'm going to go over some tech demos for that go basically into the history of so yeah, this is the advanced sending image processor, and
Do you want to just run the software? Because it's a fairly complex program. So would you mind just running the software and I'll just explain what's going on? Okay, cool. So yeah, like as Tomas mentioned, this is something that we've implemented called the density image processor. This is an analog computer graphics system, an analog computer. And Tomas has re-implemented it in HTML. The original was done in electronics, I guess. But we've re-implemented it in HTML here. So it's patch programmable. Tomas is building a patch right now, which you can see represented by these colored wires. Do you want to run the patch? Okay. Just so you can get a sense of what that looks like when a patch gets run. That's a stored patch, and Tomas is going to reload it here. So, see, he reloaded and all the patch cords went in place.
having a great amount of difficulty in getting the appointment that I want to get with either the owner, the general manager, and the concerned folks there. Now, I don't think you quite understand the problem that we got. You see, I represent a community of folks in this here United States that is deeply concerned with the transportation, communication, the telecommunication, and the teleportation systems of this United States of America in the bicentennial year of 1976, okay? And the problem is that some of us folks out here, we understand that there's a deep, deep and dire predicament of men learning how to live with machines. And that pulls into account a certain amount of attention that has to be paid to the service environment. Now, you represent service environment, and so do I. Now, us folks out here, we got our tech together. We can service, we can maintain, but the problem comes down that my truck doesn't seem to be able to be serviced and maintained.
This is a demo made by Phil Morton.
Condition is going to change for the better, and things will get all positive. And that's why we're doing this. We're
Using
working on it,
the original.
both for ourselves and for you, for all the other folks that see this here
Okay,
video.
using the original Sandine image processor, the electronic version. We have some demos that we're going to show that use our digital version. But as you can see, it has a lot of features in common with what you may be familiar with from the demo scene, and also from the Artware demo scene.
Lots of people say they don't build cars like they used to. Well, it's a good thing. Hi, I'm Bert Kramer.
The car does need service. Your Chevrolet technician does have the special tools and the special training from General Motors Training Center to do a better job.
Easy maintenance and the best service. Another reason why you've made your Chevy dealers #1, and they're not about to forget it.
Okay.
So one thing that this has in common with the Artware demo scene is that it samples other material. So like it samples television commercials and stuff, just like we sampled the Jason Scott music video. But then the music is clearly straight out of the proper demo scene. Oh, this is a spiral generator, right? Did they? Do you remember, Tomas? Did they use our spiral generator, or did they use their spiral generator?
I think they use our spiral.
Yeah, okay, so that was one that was
You
made
got
with
one
ours.
cross-eye here, and a few minutes ago, I got a call back from one.
The kind of hypnotic trance music is also pretty emblematic.
Hey, you got one. Do you really want to know how to get to Boulder, or are you just fooling around? I'm negatory. We not fooling around. We going there for sure. We're going to just stay on the 3-6 according to the map. We ain't going to have any trouble, I don't think. Why? Is there a better way to go? No, negatory. I just, said they need somebody to lead you around, so I thought if you really needed leading, I'd lead you. Hey, oh, for sure we need leading. No doubt about that. Yeah, for sure we need help. But mercy, yeah, we just looked down at the map and we go Boulder, okay, on the 3-6. Oh, we just had a problem back there with that record truck, you see.
There's another spiral.
And so this one is also really cyber psychedelic, and that's something that's very important to us. We have the same cyber psychedelic perspective, and this is clearly also coming from our cyber psychedelic perspective. But this is from 1976. So you see here the kind of analog approach using the Sandine image processor primarily in order to do these kinds of effects here. But this is also clearly intended to reprogram crickets. Usually the crickets that it would be reprogramming were those who would be making this work, as well as those who would be watching this work, like yourselves. And one thing also to point out is that our digital systems are inferior compared to the analog computers that were used to generate this material between 1971 and 1973. So we have these inferior digital systems which are only capable of rendering kind of quality level that you see here, whereas the more superior 1971 to 1973 Dan Sandine analog image processor was able to render full screen high-res video and audio at much deeper levels of density for delivering messages, those psych op codes that we were talking about earlier. Yeah, and again, so this is the digital version of the Sandine image processor.
So this is the EVL lab in UIC in Chicago, and this is also ported to HTML, and so this is actually a PDP 1145 mainframe computer, and so these are the racks right here, and then some more racks over here, and then this is the Z-Box, which is also part of this system called Z-Grass that I'm going to talk about and show you some demos of. So this is the VTO5 prompt. So basically, it also hooks up with the image processor. Okay, so they're hooked up now. I'm going to show you Tom DeFonte describe the system.
Hey, Cross-Eye. I've been reading this paper here we wrote for the National Computer Conference, and it gives a pretty good idea about the technical and computer science type things we did in this laboratory, but it doesn't give a very good idea how much fun it is around here. To give you a little cook's tour of this laboratory in the chemistry department, we'll take you over the computer here. This single bay houses the graphics computer, and this down here, of course, is the PDP 1145 computer. Behind this panel is 28,000 words of memory. This here is the disk drive, the mass storage medium we use to hold pictures and macros and other information used to run the graphics system. Up here is the A to D converters, which allow us to use dials and knobs and sliders and other things to control images. From the computer's memory go wires that go over to the vector general. And as you can see, the vector general is capable of putting up images in real time, rotating them around. What we do there is point TV cameras at them. Little TV cameras like this, which you can move around and center and get different parts of the screen. And then, because color is much more fun than black and white, we run cables over this way to a very colorful person, Dan Sandine, inventor of the image processor. Now, the basic way we do things here is that we take images from the vector general, route them via cables to the image processor, colorize them, and tape record them. Yeah. The single thing that's hardest to communicate in a paper like this is...
Okay, so that was an example of how the system works. So I'm going to show you a demo made by Jane Veeder in 1983, made on Z-Grass. So. And then there's another really interesting demo by Larry Cuba. You might have heard of him. So I actually have two demos that I want to show you by him. The first one is called Calculated Movements, and it's from 1985. Okay, and then here's the other one. This one is from 1977. Okay, so that was a circle graphics habitat in UIC Chicago. I'm going to give you a little tech demo on how we made chassis. Looks kind of like this. Basically, you have these tools right here. First thing that we want to do is add some color. So we can paint the background color, various, red, green, or blue. But I mean, it's kind of more interesting to have a lot of colors at the same time. So that's like a first step into making the chassis demo. The second step is basically adding some line art. So Let's just start drawing that. Okay, I think that's right enough right there. I think. Great. Okay, so yeah, and then let's add a new scene for the shoutouts. So here's a new scene. We want to fill it with some colors again, and then add some shoutouts, and they pull these from Pouet. So, okay. And then we want to make sure that we add escape functionality to this. So, there. Okay. So I think that basically is how the chassis demo is made, and we can compile this to an exe that you can then run and submit in demo competitions. So, yeah. So yeah, so that's basically the chassis demo making environment. We just released this. It was kind of super secret, but now, I mean, it's not going to compromise our competition anymore. So, yeah. So I think that's it.
So yeah, that's the material we brought to show you guys what our workflow is like and where we're coming from, and how other artists have used our tool chain to enable their own to build their own demos. So I guess we're not going to take any questions right now, but if you do have questions about how it works, feel free to approach us at any time. We can kind of step you through how the whole system works, if there's anything you want us to drill down on. And also, yeah, please remember to enter the secret artwork category at this year's block party. If you have something that anything we showed you today reminds you of, or something that seems like it would fit in well in the secret artwork category, be sure to do that. Okay, thanks a lot.